All right, welcome back. We're going to do lesson 3.6, removing parentheses. And when I'm saying that, and you remember that parentheses is the first step in dealing with the order of operations. So removing parentheses is the same as saying using the distributive property. So if I put our title down, removing parentheses, basically what I'm saying is that's equivalent to doing the distributive property. All right, well, to refresh our memories on what the distributive property is, let's say that we have, like example number 1, 4 times a plus 3b. Well, if we were going to solve this and simplify it, then the distributive property says that whatever is outside the parentheses must be applied to everything inside the parentheses, and I usually denote that by using my arrows. Paying attention to any sign that may be before our terms. Okay, so 4 times a is 4a, 4 times 3b is 12b. Notice that my symbol may change depending on what the symbol is before it, and here it's a positive 4 and a positive, so I'm going to have a positive 12b. I then look for opportunities to simplify, and I cannot do that any further here, so step number 1 is to distribute. Step number 2 is to combine like terms if there are any. There may or may not be any, but you need to look for those. Let's look at another example, because now I've got a negative 2 times 3x squared minus 4x plus 5. And if we are going to distribute, remember we're going to distribute the sign in front of it, so it's going to be negative 2, and we're going to apply that to the first term, to the middle term, and to the last term. Okay, so it's going to be a negative 2 times 3x squared. Okay, a negative 2 times a negative 4x, and a negative 2 times a positive 5. And so we're going to get a negative 6x squared. Negative 2 times a negative 4x, it's going to turn it to positive. A negative times a negative is a positive, becomes a positive ax, and a negative 2 times 5 is a negative 10. So we've done the distributive property. Now we need to see if there's any like terms. This is x squared and that is x. They cannot be combined, so that is my final answer. Another example. Well, what if I have 2x plus 5 plus 3x minus 7? Okay, notice that if we're going to do the distributive property, I see that there's nothing outside the parentheses here. Here I have what's essentially is a positive 1. Okay, and if there is no coefficient out here, then the coefficient will always be 1. So let's just get rid of the parentheses. Here, since there's nothing on the outside, we just drop them. Here I apply my positive 1, so it'd be positive 1 times 3x is 3x. Positive 1 times a negative 9 is 9. And then I go through and I look for opportunities to combine my like terms. I have 2x and 3x, and I have 5 and a negative 9. And I like to do the underlining, or I could circle the items that are like terms, and then that produces my answer. So 2x plus 3x is 5x. A positive 5 minus 9 is a negative 4. So we have 5x minus 4. All right, let's try another one. You have 5x minus 7 minus x minus 6. It's imperative that you understand the distributive property, or you're going to have difficulties with these problems. Okay, so here again I don't have anything outside the parentheses, so I'm just going to drop them. 5x minus 7. Here I'm applying a negative to everything inside, which is going to change the sign of everything. So I'm going to get a negative x plus 6. A negative times a negative is a positive. Okay, again, I combine my like terms, 5x and a negative x. Don't forget the sign in front of your term. It's part of the term. And then I have a negative 7 and a positive 6. So I get 4x minus 1 is my final answer there. Let's look at another one. Let's change colors here. We'll go back to black. Let's say I have 4a times a plus b plus 3 times a squared plus 2. Okay, and we're going to apply that 4a to everything inside the parentheses. And if you need to draw these arrows, I recommend you do it until you become a master of it. 4a times a is saying 4a squared. A times a is a squared. 4a times b is 4ab. 3 times a squared, or 3a squared, 3 times 2 is 6. I look for my like terms, and I can see that my like terms is the a squared. So I can combine those and get 7a squared plus 4ab plus 6. And that becomes my final answer. All right, so we're starting to combine multiple steps now into these problems as they're getting more and more difficult. And a failure to understand distributive property, a failure to know when I multiply a times a, I get a squared, not 2a. Those kinds of deficiencies will now show up and magnify themselves, and so you got to pay attention to all the rules that we've learned at date to get these to be successful with these problems. Good luck. Try the odd problems. Don't forget that you are responsible for taking notes and including in your notes all the example problems worked through in detail so that I know that you are actually covering the material.